Welcome to Lab 4. This Lab 4 has 8 chapters, and in all these 8 chapters my focus will be mainly on what kind of database design should a typical Power BI project have. If your DB design is not having the right architecture, then your reports would become tremendously slow as your data grows. So in this lesson, we will focus on two important designs. One is the star schema design and the other one is the snowflake design. But first, let us discuss the nature of Power BI data and then we will check out what kind of DB design suits for the same. When we talk about Power BI helps us to show analysis data. So in other words, we would like to show aggregated data or uh, summation kind of data or average kind of data. So we would like to show aggregated data. For example, you can see here product wise sales. You can see here country wise sales. But Power BI is not really meant to show individual records. For example, I don't want to go and see the individual customer entries. So this Power BI tool or visualization tool is more to show analysis data for the top management or for the mid management or for the sales or so on, right? Where they want to quickly get a picture that what is happening and what action to be taken. So we can say that the design needed for Power BI is more of an OLAP design, online analytical processing. OLAP kind of databases are those databases, wherein our goal is to go and select faster. We want to retrieve faster, right? So when you talk about Power BI, the backend design should be having an OLAP design. The other kind of database, we can term it as an OLTP database. In OLTP database, we have more actions related to insert, update and delete. So we want to ensure that whatever data goes into the system, it should not be duplicate, it should not be redundant. So over there we follow normalized design like first normal form or second normal form and third normal form and so on. While in case of an OLAP, we want to search faster. So here we follow more of denormalized design, wherein we try to club two tables and we want to put the data in only one table. So we want the selects to be faster. So when you talk about the nature of databases, there are two kinds. One is OLTP, one is OLAP. So in OLTP, we follow the normalization design, and in OLAP, we follow the denormalization design. In case you are new to first normal form, second normal form, and so on, I would suggest to go and watch the SQL Server videos where we have explained in more detail. But in this video, my goal is to talk about the denormalized design. So the first point is Power BI works on analysis data. So we need to ensure that our design follows the OLAP principles. The second thing is when you talk about analysis, at the center, it is the number. There is a number on which we do the analysis. For example, over here, we are talking about sales product-wise sales, product-wise, country-wise sales, country-wise population, region-wise population. So always in the center, there is always this number on which we want to do the forecasting, on which we want to do the analysis and so on, right? So there are two kinds of database design which is very prominent in OLAP. One is the star schema design and the other one is the snowflake design. So you can see here, I am on the Power BI database and let me go and create a new database diagram. So I'm going to go and create a new database diagram and let us go ahead and design a simple database which follows star schema and snowflake. Now in star schema design or snowflake design, there are two kinds of tables which are involved. One is the fact table and the other one is the dimension table. In the fact table, we put only numbers on which we want to forecast, numbers on which we want to do the analysis. And the dimension table talks more about the fact table. So if you see, for example, now let us say we want to create a sales OLAP, right? So I'm going to have on the center a fact sales table. In case you are new to SQL Server, in case you are new to these database diagrams, I would suggest to go and watch my SQL Server videos. So let's say that this is a sales table, wherein we have a sales ID, we will have a sales amount. So this fact table will have that numerical value on which we want to do the analysis, right? So you can see now this is the sales amount, but sales amount as per what? Like sales amount as per country, sales amount as per region, right? So the dimension table they talk more about the fact table. So for example, I can have a dim country out here, and this dim country will again have let's say an ID. It's always good to have a primary key in every table. And let's say here we have the country name, right? So now we want to say that, okay, this sales amount as per country. So what you will do now is you will have here a country ID underscore FK, a foreign key. So this is the primary key and this is the foreign key. So you can see here I'm dragging and dropping. So the primary key table is dim country and the foreign key is in the fact sales, right? So now over here, this dim country is the dimension table. In other words, it has the text, right, which talks more about the amount. So country wise sales. In the same way, I can have must be a new table here. Let's say a dim product, right, which again has a product ID as a primary key and a product name, right? And over here I will have product ID underscore FK. So this is the primary key table and this is the foreign key table, right? So you can see here now, this is called as the star schema design. In the star schema design, on the central, you have the fact sales table, wherein you have the numerical amount on which you want to do the prediction, on which you want to do the analysis. And then the dimension table actually more talk about that sales amount, right? So we can also think about that fact sales table is more about a numerical value. So they more talk about a numerical value, while the dimension table, they more talk about some textual value. Now, whenever you are designing the star schema design, right, ensure that you try to follow denormalization. Denormalization means we try to put as much as data as possible in a single table. For example, now, let us say that I want to get country-wise and states-wise the data. So country has states, right? So what I will do now is I will not go and create a separate dim states table, but what I will do is I will go and I will put the states ID out here. So you can see here the way I'm changing my design. So this is the country ID, states ID, states name, right? So I did not create, a different table, but I did it in the same table. And what I can do is I can create a joint primary key on the states and the country. So here now I can have the states ID underscore FK, no problem, right? And the relationship between these two primary keys will actually go to country ID as well as states ID. So I will say that, okay, this is a joint primary key and it should be mapped to the joint foreign keys out there, right? So you can see out here, I did not create a separate table called as dim states, right? So I do know that I will have duplicate data, but I'm fine with it because the more the tables I try to select from, the more my query will become slow. And the more I try to select from less amount of tables, I have less amount of joins and my select will be faster. So you can see my dim country is created, my dim product is created, right? So the dim product, is this table, dim country is this table, right? So all the things are created out here. So you can see one India, one of the province and the state is Punjab. In the same way for Nepal, we have Godavari. In the same way again for India, we have one more states here called as Maharashtra, right? Now you can see India and India is duplicate out here or redundant, but we have purposely done it so that we don't have to fetch from multiple tables and our query can be faster, right? So we understand it. So one of the issues, with redundant data is it is possible somebody can do like this, India 2 and somebody for Maharashtra can just say MH, right? Now this can create problems. You can see now you have redundant data here, duplicate data here, right? So what you can do in such kind of scenarios is you can go ahead and create a snowflake design. In a snowflake design, what people do is they actually, so in the snowflake design, oops, right? So in the snowflake design, what we will do is, my database diagram is not working. That's so sad. That's one of the bugs which we have in SQL Server. So in Snowflake design, what we do is we create one more table called as dim states. So because of this redundant data, what you can do is you can go here and create one more table called as dim states with states ID, right? And states name, right? And I'll just say set it as primary key, and I'll say dim states, right? And from this dim country, I will go and I will remove those two fields from out here, right? And I'll remove the fields from out here. So here I will now say, so this is country ID will be the primary key, right? But this dim states table, so the dim states table will have a reference of the country. So you can see here in the dim states table, I will go and I will refer a country ID underscore FK, right, on int. So I restarted my SQL Server Management Studio to just make sure that if we can make the diagrams working, and I can see that the diagrams are working. It is typical of Microsoft, they have these bugs, which are floating around. So you can see now what we are ending up here is that the dimension tables also have child tables attached to it. So you can see this country ID is now a foreign key out here, right? And over here we will have, okay, I did something wrong. Yeah, that's a foreign key out here. And the dim country will refer to the country ID only. And the dim states as well as will refer to the states ID underscore FK. So you can see now this is the snowflake design. In case of a snowflake, what happens is the dimension tables will again have relationships between them, right? Just let me make sure if this I have done properly. So country ID is here. Yeah, country ID, primary key, and foreign key country ID underscore FK. Okay, just wanted to make sure if I'm doing the right thing. So you can see now in star schema design, the dimension tables do not have further tables, right? In case of a snowflake design, the dimension tables have, further relationship as well, right? So now when to use star schema, when to use snowflake, it all depends actually. If you think that you want to make your query as fast as possible, then definitely I would say that stick to star schema design and do not worry about the duplicate data. Just try to make sure that you have proper data at place, right? But if you say like, no, like I'm getting a lot of redundant data, I want to just make sure that even the redundant data is resolved, right? Then you should actually then create this dim states table or a table which is having a foreign key. But please note that if you create more tables like this, you will end up into a normalized design. And then again, it's possible that your queries can become slow because now you are selecting from a lot of tables, right? So this is the snowflake design and we will stick to this for now. So you can see that I have inserted the data into the tables. You can see I have inserted data into dim product, product 1, product 2, in the states table, in the country table, in the states table. In the states table, we have to give the mapping between the country and states. I have done it. And in the fact sales table, I have made some data entry manually, right? So now let us go back to Power BI and what we need to do to connect here. Now things become very easy because with this kind of design, wherein we have the fact table centrally and we have the dimension table surrounded, it becomes very easy to do visualization. So you can see here now, I'll just say Power BI, that's our database. And we want to select the dimension tables and we want to select the fact sales tables. Other tables are from the old exercise, so we'll just leave it. So if you see, once the data gets loaded, the first thing is internally also in Power BI, the model looks much better. So you can see here, these are our dimension tables and this is our fact table centrally, right? So this is the snowflake design. Why? Because the dimension tables also have relationships. So now with this kind of design, it is very easy to go ahead and create visualization, because now we can say, okay, let's say a stacked bar chart. So what we want to do the visualization? Sales amount. So we select sales amount, and what is the dimension? So we can say, okay, we want country name as a dimension. We also want the product name as a dimension. So you can see now the way we do our visualization becomes more uniform and more standardized and more organized. And also definitely it is more efficient because this is a denormalized design, right? So the number of tables from where the query will fetch the data is very less. So whenever you talk about Power BI, at the end of the day, it is all meant for analysis. And for analysis, it is very important that we have either the snowflake design or either the star schema design. Now, this database structure, what I have here, right? What I'm doing is, when you're watching this video, I have given this database structure as a download in the .sql file. So you can see that you will see a file name as lab4 SQL structure. So, right. So you can go and you can download this file and you can open this file like this. So this will get opened into your SQL Server Management Studio, right? So it should get opened into SQL Management Studio. Oh, it's okay. It's opening into MySQL because I also have MySQL. So I want to open that file into SQL Server Management Studio. So in other words, let me just go ahead and drag and drop like this. So you will see something like this. And what you can do is, in order to just create the structure very easily, create a new database, like let's say new Power BI. And sorry for the spelling mistake. New Power BI, right? And then you can go here and run this script inside the new Power BI. You can see here I'm just saying new Power BI. So just run the script inside it. So if you say execute, you will see that in your new Power BI, all the tables will be created. So you can see here all the tables have been created. So you can get this file from this video download. So wherever you are seeing this video, you should see a download link. In case you don't get the link, you can please mail me at questmont@questmont.com. If you do not know how to create the database, you can mail me as well. I can probably help you out in more detail. So that brings us to the end of this video. After this video, I'm flashing some questions. Please try to answer those questions. So keep learning. Thank you very much.